In electric scooters, the conventional method for connecting motor phase wires to the controller involves securing them with screws to copper lugs. This method is convenient as it only requires fastening 2 sets of phase wires onto a base with screws. However, it has consistently exhibited certain issues. 1. Inconsistent torque on screws. The inconsistent torque applied to the screws leads to operational faults in the vehicle. The phase wires may begin to heat up, causing the outer insulation of the wire harness to melt. 2. Deformation of base during heating. As the base heats up due to the high temperature of the copper lugs, it results in the loosening of screws, leading to poor phase wire contact. This further exacerbates the heating at the connection points, contributing to the melting of the phase wire insulation. To ensure a reliable connection between the motor phase wires and the controller, riders need to frequently check if the screws are properly tightened. In pursuit of reducing the failure rate of phase wire connections and minimizing maintenance costs, we have been searching for a suitable alternative. Recently, we found a specialized manufacturer of high-current connectors and have customized a connector, EC8-S. The connector manufacturer claims that it can withstand a rated current of 150A and a maximum current of 200A. However, precise data is not currently available, e.g., what is the temperature rise when carrying a continuous current of 150A for 1 minute? Will the connection fail at 200A? To determine if this connector can meet our requirements, we conducted an experiment. We connected the conventional screw-fastened copper lugs in series with the EC8-S connector. We used a Fluke IZTC01A thermal imager to observe temperature rise in the circuit. To account for differences in the infrared characteristics of different metal materials, we applied a layer of insulating tape to the connector. During motor operation, we applied belt braking to provide resistance to the motor, testing it under high current conditions. We measured temperatures at various points along the phase wire circuits. Preliminary assessment indicates a lower temperature rise for EC8-S. Further testing of EC8-S is planned. As the EC8-S relies on metal elasticity for its contact, we intend to leave samples in place for an extended period and repeat the tests to verify any changes in its characteristics. Additionally, we plan to install EC8-S on the scooter for further testing.